In this video, we'll try to understand how data flows in a React application. A React application is made up of a number of nested components. This results in a hierarchy that starts with a parent component and branches down at various levels. When visualizing data and how it should flow in an application, it is logical and easier to imagine data flowing down from a parent to a child like a waterfall. This is one of the reasons why React implements a top-down data flow architecture where data is stored and originates at a parent level and flows down components using props. Many other web frameworks such as Angular feature two-way data binding, in which case changes to the data model results in a change to the view and changes to the view automatically updates the data model. While this sounds like a great idea, it has the potential to pose challenges in keeping track of how updates actually happened and the predictability of the process. This is true especially for large applications where it may be impossibly tough to reason and predict data model mutations. On the other hand, in the case of React, the view is essentially a function of state and props. The state in this case is the single source of truth and all updates are a result of the state. Practically, the state is typically located at a parent level. This does not necessarily have to be the topmost parent or root component in the application hierarchy. For instance, a toggle button component may incorporate its own internal state to keep track of the toggle state of the UI. But wherever state is located, the data can only flow downwards to child components using props, and therefore only children can access the state. As a result, you will observe a cascading waterfall of data reservoirs or state that spill down to components using props. This is what we call as one-way or top-down data flow architecture. This architecture means that a child component does not need to know where the data is coming from or where in the hierarchy it is stored. Additionally, there is no way for a child component to know if the parent is a stateful or a stateless component. All that a child knows is that it receives data typically using props. So, to sum up, the only way to update the view is to update the state, and this data is passed using props to child components. And since we can predict that, and the way data flows down one way through props, we can easily predict UI behavior. Now, having said all this, what if a component wants to send data back up the chain to a parent? For instance, a form field component would like to send data back to the parent to update a state variable. In this case, we can implement an inverse data flow by implementing callbacks in props to run functions on the parent that actually update the state. Here you can see a form component that invokes a function in a prop whenever its contents change. The actual function, however, still resides in the parent. This means you still have a pretty clear implementation of a one-way data flow architecture, and React only makes it explicitly known if and when you want to send data back up the chain. And even when you do so, the actual changes to state are still done by functions that reside at the parent, which makes the process abundantly legible and easy to understand. Now, having said all this, what are the challenges that we might face with React's one-way data flow architecture? Let's find out in the next video.